Good morning, children. Welcome back to the class. Today we will continue with where we have stopped previously, that is exercise 10.2 mensuration. Exercise 10.2. We have completed fifth problem. Now let me start from problem number 6. It is a sphere, a cylinder and a cone have same radius and same height. Find the ratio of their volumes. So very interesting question. Here a sphere, so here we have a sphere, and next they have given a cylinder, next they have given a cone, so these three pictures, sphere, cylinder and cone, they are having same radius and are of same height. So sphere, cylinder and cone have same radius and of same height. So here heights are same, let it be h. This height is also same, it is h, and the height of this one, so height h. When we say that heights are same, it is nothing but it is diameter. D is equal to h. So it is what? H is equal to 2r here. H is equal to 2r. Now what did he ask to find? The ratio of their volumes. Now ratio of their volumes. He asked to find ratio of their volumes. Fine. Ratio of their volumes, that is what? Volume of a sphere is to volume of a cylinder is to volume of a cone. Right, children? So here, when it is, what is the formula for volume of a sphere? It is 4 by 3 pi. Let us take it as r1 cube is to volume of a cylinder. Volume of a cylinder is pi r2 square h1 is to volume of a cone, that is 1 by 3 pi r3 square h2. We know that r1 it is equal to r2 is equal to r3. Okay, so let r1 equal to r2 equal to r3 is equal to some r. Okay, and in sphere we know that h it is equal to 2r in sphere. So this I can write it as 2 by 3 times of pi into 2r into r square. Can I? Because here in this 2 into 2, this is 2 mixed with r, so 2r into r square is 2. Pi into r2 can be written as r square into heights are also same, so h1 will be equal to h2, so even heights are same, so it is written as 1 by 3 pi here r square h. Now here 2r I can replace it with h, so 2 by 3 pi, it is h into r square is 2 pi r square h is to 1 by 3 pi r square h. So what is common? So pi r square h, pi r square h, pi r square h is common. All will get what? Cancel. So that what is left? 2 by 3 is 2. Here 1 is 2 because nothing is common here, and 1 by 3. Now multiply this one with 3. We will get our required answer, that is 2 by 3 into 3 is to 1 into 3 is to 1 by 3 into 3. It is written as 3 get cancels, so 2 is to 3 is to 1. So ratio of their volumes, therefore ratio of their volumes is 2 is to 3 is to 1. Right, children? Come on. Now let us move to the question number 7. Here we'll go to the next page. Now question number 7. A hemisphere is cut out from one face of a cubical wooden block such that the diameter of the hemisphere is equal to the side of the cube. So determine the total surface area of the remaining solid. So here a cubical wooden block is there. This is question number 7. So a cubical wooden block, in that what? It was curved, a hemispherical. A hemispherical is a hemispherical cut, it was done. Okay, so here what did he ask to find? Determine the total surface area of the remaining solid. He asked to find the total surface area of the remaining solid. So here if we see into that question, so what we get here, what is the total surface area of a cube? So first, a cube, what is given? A cube, a hemispherical cut from one face, a hemispherical cut from one face of a cubical wooden block. So it was curved out. Now we need to find the total surface area of the remaining solid. Now total surface area of the remaining solid. So we need to find surface area of the remaining solid. So surface area of the remaining solid is nothing but surface area of cube minus, it was, say, on the top we have made a circle, that was, we need to subtract that area, that is area of a circle on the top minus area of a circle on the top plus the curved surface area of CSA of, it is added, the curved surface area of the what, hemisphere. Now if we see into the this one, so diameter of the circle or diameter of the hemisphere, so diameter of the hemisphere, it is actually, it is equal to the side of a cube. If we look into that, that is D, it is equal to S, that implies 2R is equal to S. So R is equal to S by 2. Simply we can take it as R is equal to S by 2. So when we understand the concepts clearly, then the way of solving the problem will be quite easy. Now substitute in that, so area of the remaining solid, sorry, so area of the remaining solid it is equal to, so surface area of cube, that is surface area, it is 6 s square minus area of circle, it is what, pi r square plus curved surface area is nothing but 2 pi r square. So pi r square minus 6 s square, 2 pi r square minus pi r square is what, pi r square. Here r value is what, s by 2, let me substitute that one. So 6 s square plus pi into s by 2 whole square. So this changes to 6 s square plus here pi into s square by 4. So in this s square is common, it will be 6 plus pi by 4 square units. So what we have got finally, that is area of the remaining solid, that is wooden part, it is given as s square whole times of 6 plus pi by 4 square units. Now let me move to the last question from this exercise, that is question number 8. Problem number 8, the wooden block, here an wooden article was made by scooping out a hemisphere from each end of a solid cylinder. So they have given that it is a solid cylinder. Now let us take a solid cylinder here. From this solid cylinder, what they have scooped the hemispheres. So we have two hemispheres, one hemisphere it is scooped at the bottom, yeah. Yeah. Now this one, so this is how it was scooped. Now we need to find the area of the wooden block, total surface area of that what article. So here a article was made by scooping. Here article is made by scooping article is made by scooping hemispheres each end of cylinder, and height of the cylinder it is given as 10 centimeter. Height of cylinder is equal to 10 centimeter, and the radius of the base, so radius of the base is equal to, it is given as 3.5 centimeters. So even radius of the base, this is for the cylinder, so these dimensions are for cylinder. Now let us take for hemisphere. Hemisphere also it will be the same, so radius of hemisphere is also equal to 3.5 centimeter. Now what did he ask to find? He asked to find the total surface area. Total surface area of article. So total surface area of article, it is nothing but what? Curved surface area of cylinder plus 2 times curved surface area of hemisphere. So curved surface area of cylinder. So curved surface area of cylinder is pi r1 square h1 plus 2 times curved surface area of hemisphere, that is 2 pi r2 square. So if we look into this, it will become pi r1 square h1 plus 2 into 2 is 4 pi r2 square. We know that r1 is equal to r2. We know that r1 equal to r2 and it is equal to 3.5 centimeter. 3.5 centimeter. If we take, that is, no, r1 and r2 is equal to, let r1 is equal to r2 is equal to r. So here it will become pi r square h plus 4 pi r square. Sorry children, this is wrong. It is curved surface area we are supposed to take, and I have written the formula for. Now it is 2 pi RH R1 H1 and it is again 2 pi R1 H1. So here it will become 2 pi RH plus 4 pi r square. So in this 2 pi r is common, so take 2 pi r as common, then it will become h plus 2r. So 2 into 22 by 7 into r value is 3.5, and it is h value, we know that h value is equal to 10 plus 2 into 3.5. So here 3.5 ones are 3.5 twos are 2 ones are 2 ones are, so it will be 22 into 10 plus 7, so 22 into 17, 17 twos are 34, 4 2 carry, 17 twos are 34, 35, 36, 364 square centimeter. This is all about the 8th problem. So I hope the exercise is done. Now we will move on to the next exercise, that is exercise 10.3. So again it is a combination of solids, same, but in this chapter many problems we have deal with what, volume related. Now we are going to deal with the surface area in exercise 10.2. now we are going to deal with the volume. So this is a very important exercise. So let me start the next problem, that is the first problem from exercise 10.3. so exercise 10.3, first problem. So an iron pillar consists of a cylindrical portion of 2.8 meter high and 20 centimeter in diameter, and a cone of 42 centimeter height is surmounting it. So there is a cylinder. Now let us see the diagram. Here there is a cylinder. On this cylinder we are having a cone. So there is a cone, and this is mounted on this. Fine children, this is how that solid will be in the shape. Now the weight of the pillar, we need to find. If 1 centimeter cube of iron weighs 7.5 grams. See children, this is all about volume problem. So volume related. Here what they have given, an iron pillar, of cylindrical shape, with a cone it was surmounted. So the height of the cylinder, it is given as 2.8 meter. Height of the cylinder, let it be h1, it is equal to 2.8 meter. We can write it as it is equal to 280 centimeter. And the conical part, this height, let it be h2, and the height of the cone, it is given as 42 centimeter, and there they have given the diameter of the, for both it is diameter, it is equal to 20 centimeter. Now we need to find the volume. So here let us write in detail about the cylinder, dimensions of cylinder and dimensions of the cone. Here height h1, it is given as 2.8 meter, so simply it is written as 280 centimeter because everything is in centimeter. Even the weight also they have given in centimeter cube only, so height is centimeter. Diameter d is equal to 20 centimeter, so this one it is common for both, so r we can write it as simply it as r is equal to 10 centimeter. For cone it is h2, it is given as 42 centimeter, and here also d is equal to 20 centimeter, that means r is equal to 10 centimeter. So here let it be r1, r2. We know that r1 is equal to r2. Let r1 is equal to r2 is equal to r, simply r, and it is equal to 10 centimeter. These are the dimensions that they have given. Now volume of solid, volume of solid, it is equal to volume of cylinder plus volume of cone So volume of cylinder, if you look at the volume of cylinder, the formula is pi r1 square h1 plus volume of cone, we know that it is 1/3 of pi r2 square h2. We know that r1 and r2 are same, one and the same. So here that is pi value, let us take it as 22/7. So pi r square h1 plus 1/3 pi r square h2. So pi r square is taken as common, it will become h1 plus 1/3 h2. So pi value is 22/7, r value is 10, so 10 square. H1 value is 280 centimeter plus 1/3 times of 42. 3 ones are, here it is 3 ones are 3, 3 14s are, so it will become 22/7 into 100 into 280 plus 14, it is 294. So 22/7 into 100 into 294. So 7 ones are 7 4s are 28 and 2s are, so multiply this 2. 2 into 2 is 4, 2 into 2 is 4, next 2 into 2 is 4, 4 plus 8 is 12, 2 1 carry, 2 4s are 8, 924 into 100, it is written as 92400 centimeter cube. Now actual what did he in the next, not only to find out the volume, we need to find the weight, and here he had given that weight of the pillar, if 1 centimeter cube weighs 7.5 grams. So weight of pillar we need to find, it given that 1 centimeter cube is equal to 7.5 gram. Then we need to find for 92400 centimeter cube weighs how many grams. So simply it is 92400 into 7.5, right children? And now 75, here 2 zeros as it is. Now 75 4s are, that is 300, 0, and here it will be 30. 75 2s are, it is 150, 180, 8 is 0, 18 carry. Now 75 9s are, 75 10s are is 750, that is 675. 675 plus 18, that is 693. So 693. So we have one decimal, so it is grams. Now you can convert this one into kgs, that is 693,000 by 1000 kg. So 3 zeros will get cancelled, it is 693 kgs. So what is that weight of the pillar? Weight of the pillar is 693 kgs. I hope you have done with this problem. Now let me go with the next question. So question number 2, a toy is made in the form of a hemisphere surmounted by a right cone whose circular base is joined, okay, with a plane surface of hemisphere. The radius of the base of the cone is 7 centimeter and volume is 3 by 2 times of hemisphere. So here what is given, actually a hemisphere is surmounted by a cone. This is a regular picture that we have come across with. So the diagram is like this, and what is given, the radius is given as r, it is given as 7 centimeter. It is radius is given as 7 centimeter. Here question number 2, a toy is in the form of hemisphere surmounted by a cone whose base radius is 7 centimeter. Whose base radius is 7 centimeter. Here he asked to calculate the height of the cone and surface area of the toy. Height of the cone we need to find. One more thing they have given, here volume of a cone is equal to 3 by 2 times volume of hemisphere. Volume of a cone volume of hemisphere volume of a cone equal to 3 by 2 times. So he asked to find first height of cone. We need to find height of a cone, then we need to find the surface area. Now volume of a cone, we know that formula of volume of a cone is 1 by 3 pi r square h, and it is equal to 3 by 2 times of volume of hemisphere, that is equal to 2 by 3 pi r cube. So here if you see 3 get cancels, 2 get cancels. Now it is equal to 1 by 3 pi r square h. It is equal to, I can write this one as pi r square because the radius for both here r1 equal to r2, it is equal to 7 centimeter into r, radius equal to. So here pi r square we can cancel, so it will be h by 3, it is equal to r. So here the value of h value we need to find h by 3. We know that r is equal to 7, that implies h is equal to 7 into 3, that is equal to 21 centimeter. Therefore height of cone is equal to 21 centimeter. Now he asked to find the total surface area of the toy. So total surface area of toy, it is equal to CSA of hemisphere plus CSA of cone. So CSA of hemisphere, we know that it is 2 pi r square, but CSA of cone is pi r l, pi r l. So we don't know the value of L. We know R value is equal to 7 centimeter, H value is equal to 21 centimeter. We don't know the value of L. So L, first calculate L, square root of R square plus H square, that is 7 square plus 21 square, it is equal to, in this if you see clearly 7 square we can take common, because I can write this one as 7 square plus 7 square into 3 square. So 7 square if we take common, so 7 will come out and it will become 1 plus 3 square. So that is 7 into 1 plus 9, that is root 10, and the value of root 10 is approximately like 3.16. so this I can write it as 7 into 3.16. so 7 6 are 42, 2 4 carry, 7 1 is 7, 7 plus 4 is 11, 1 carry, that is 22.12 centimeter L value. Now calculate that one. Here it is 2 pi r square plus pi r L. In this pi r is common, so take pi r common, so it will become 2r plus L. So pi r, 22 by 7 into r value is how much? R value is 7 into 2 into 7 plus L value is 22.12. 7 get cancels, so it is 22, it is 14 plus 22.12, so it is 22 into 14 plus 22 is 36.12. so 22 2s are 44, 4 carry, 22 1s are 22, 22 plus 4 is 26, 6 2, 22 6 are 132, 132 plus 2 is 134, 4 13, 22 3s are 66, 66 plus 13, here 66 plus 13, it is 79, so 794.64 centimeter square. So total surface area of the toy is how much? Therefore total surface area of toy is 794.64 centimeter square. Right children? Yeah, have a nice day children, take care, we'll continue in the next class.